welcome back to my bench. Today on the bench we have a Racal F77 20 megahertz log linear sweep generator. I bought this thing a long time ago, and it supposedly was working. When I got it, not so much. It sort of worked in some modes, but in other modes it just didn't. So I did get it fixed, and I thought I'd give you a quick demonstration of how that happened. Finding any information on this thing on the web is virtually impossible. I found a video on how it works, and that was about it. Getting a manual for it was even harder, so I ended up buying one on CD, and it worked quite well. The manual was pretty good. It was from one of those people that makes manuals, and I didn't quite understand how this thing functioned when I got it, because it's a fairly complicated little piece of equipment. It took me a while, but I finally got it down, and I'm not going to take you through the full repair. Let's just say that there were parts broken, which I'll show you. Somebody had been in here with a magic screwdriver. Unfortunately, the magic wasn't really all that magical. But anyway, it was fixable. Now, there's a couple of things you have to understand about a function generator. Yes, this will go to 20 megahertz. However, this is not what I would call a signal generator. It's just not that stable, and none of them are. The new ones, I suppose, the DDS, the ones frequent, the little ones you can buy for 80-some bucks or whatever, that we've done that we've looked at in the past. Those are pretty stable, and they make pretty good signal generators for what they are. But what this thing is designed to do is be a sweep generator, and it does a pretty good job of that. This knob, this dial on something like this is not going to be perfect. It just never will be perfect. It can't be. The thing is not crystal controlled. It's all controlled through LC networks, a capacitor and a coil or whatever to give you the frequency. So you could tune this thing to your heart's desire, and you are never going to get dead on this knob. It's going to be within a given amount. And even the manual says that it's only good to 1%. That's it. I mean, you set this thing on 5 megahertz, and it's going to be good 1% of the dial. So you got to remember that. However, if you're going to tune up, say, a 455 IF with it, you set it on 400 kilohertz and 500 kilohertz and let it sweep across that, and that's all. That's fine. That's what you need to know, and it's not going to be that touchy about being on frequency. The way this particular one works is you have all of your different various controls over here for what it'll do, and it'll do quite a bit. This control here, this allows you to go from times 0.001 of whatever this dial is on, which is like if you have this dial on 5, it'd be 0.005, and even down lower than that, it'll times 0.01 times 0.005. So this thing will go from really long time frequency down, well, 0.001 times 0.005. I'll figure it out in the video when I do the post on this thing. Then you got times 1 and times 2. When you put it up here, like let's say you have it on times 100 and you've got it on times 1, whatever on the dial that you've got, it's times 1 times 100, so this right now would be on 500. And then if you take it up to times 10K or 10,000, 1 times 10,000 times 5 is, that would be 50,000. Then you've got a times 2 scale, which is underneath this scale here, and it would be double whatever it's showing. So this would be 10 times 10K. So it'd be, 100K, all the way up to 20 megahertz. If you go up to here, which says 20, then you got 20 megahertz output, and that's exactly what it'll do. So it's fairly wide ranging. Let's see, this dial over here, this gives you your sine wave offset. Either the sine wave is in the center of the 0 offset, above it, below it, or variable offset, high and low, so that you can swing your output above or below the 0 line. This one over here, this gives you your waveforms. You have a sine wave, triangle wave, square wave, DC, straight DC output. Come down here and you've got pulse, which is controlled by a combination of this inside knob. This inside knob will give you, I can't see it from here, microseconds, milliseconds, and nanoseconds, from 0 to 100 or 0 to 1,000, depending on where you've got it set. And this will give you your width of that pulse. Also, this will go down one step below it, and it'll give you your sweep ramp at this output, so that you can have a whatever your sweep is, the ramp that goes up. As the ramp goes up, the sweep increases. This is a voltage controlled oscillator, and as the ramp goes up, the voltage increases, the frequency increases on the output. And this is a way of seeing what this is. Sort of the same as over here. This is a sync out, only backwards. However, you can invert it. You pull that out and you can invert your ramp. Down here, this one has got your output attenuation. This particular thing will go from 15 millivolts, or way down. It'll almost go off. It says 15 millivolts, all the way up to 15 volts output, and it's fairly accurate. Does a pretty good job. This is this knob here, the inside knob, or the outside knob here. These are your different forms of sweep and output. This has burst mode, which will just give you a burst of your frequency that you, whatever you got it set for, and burst across your sweep. You've got a sweep and hold, which is kind of nice. You hit this, and or when you hit the button here, it'll sweep across your frequency and hold at the last. Unless you turn this backwards. Let's see. If you turn the sweep and hold, if you reverse it, it'll go the other direction. it'll go backwards for you. Then it's got a triggered sweep where you can just have it set, hit the button, it'll sweep once across and stop, go back to whatever your lowest is. Then it's got a continuous sweep, just sweeps and sweeps and sweeps. This particular unit does not sweep and then come back and sweep and come back slowly. This goes out, retraces, out, retraces. So if you've got a second sweep, it'll sweep across, bang, sweep across, and then come back. Then it's got gated. That's for an input. You can put an extra input here to gate it. Gate your sweep on and off. It's got a triggered well, it'll just be a frequency generator at this point, and then you hit the button and it'll start. Then it's got a continuous, just continuously sets out a frequency, just a frequency, not a swept frequency. So it does all of those different versions of sweeping and standard outputs. The inside knob of this particular one is a sweep time, and the sweep time on the outside knob goes from 10 to 1,000 seconds. 1 second, and this internal knob here controls that. You go from, well, if it's down here in 1 second, it never will sweep, and then you just turn this up, and then that's 1 second sweep. What is that, 100 milliseconds? I think it's milliseconds. Hard to see in this direction. Yeah, 100 milliseconds, 10 milliseconds, 1 milliseconds, 100 nanoseconds, 10 nanoseconds, and off. So in this position, it's off. And this knob just controls that sweep time to a maximum of whatever's on this dial. This knob is the trigger, internal trigger for the sweep, so that you can adjust it so that it triggers just to where it needs to starts to go. This is when you've got this thing in either sweep and hold or triggered sweep or one of those, this hitting that button will start it, and excuse me, when it's in sweep and hold or gated, it will, doing it backwards, this direction will set it back to where it was. So if you go this one, it will go sweep and hold and stop at whatever frequency you've got set up for as a stop frequency, and then hit it again and it'll go back to your start frequency. So it's sort of a manual sweep. This here is the phase of your sweep, so you can set the thing so that it's a little out of phase depending on what you're doing. It's something you don't use a whole lot, but it also has a VCF in, so that you can put your own voltage in here and control the sweep or the frequency with an external voltage up to about 5 volts. Yes, it's 5 volt span. This is your triggered sync in. This is you can use an external trigger to get the thing to start sweeping or to stop it. And this is your sync out, which you can take out to your to a scope or something and use it as a trigger for the output for your sweep, so that you can watch it on the scope. It also has, in that way, you have the sweep output here, which they call, sweep ramp. This will give you an actual ramp up. The ramp goes up, down, up, down. So you can use that to see the ramp, and also you could use that for a trigger, I guess. And then it has analog, frequency analog out, which reduces it and tracks along with this for your analog frequency out. As far as this knob is concerned, this is kind of unique that I've seen. I haven't had a lot of these, but sweep generators, I've got a couple. But basically what you do is you set whatever you want for your frequency. Let's say we're going to go 1000. So I want to sweep audio range, let's say we're going from 100 hertz, and I want to sweep this thing up to 600 hertz. Why? I don't know, but let's do it. So you'd set this one, the main dial, on 100, and it's got this neat little vernier in the middle and rough on the outside. And then you set this knob so that this little pointer here, if you can see it, there's a little pointer right there. Sweep that, or set that on your ending frequency, which we'll put down here at 6. And now when you sweep it, it'll go from 100 hertz to 600 hertz. So it is kind of limited in the fact that you can't sweep any farther than the end stop here. So this would go from 600 hertz to 1000, or to let's see, I'm on times 100 that's 600 hertz to 1000 hertz. So it is kind of limited in that way. It's also, if you think about it, let's say you drag this thing back up here and you want to go from 900 hertz. Well, if you start at 9, you can only sweep to 10. So you go 900 hertz to 1000 hertz. That's as far as this thing will let you sweep. However, you can change your output multiplier and take this thing back down to 900, and now you can sweep up to times 10k to 10k. That's why this will go backwards a little bit. Off of 1, it'll go all the way down to won't go to 0. It'll go to 0.01 as far as it'll go. So it is a little bit limited in that way, but it's good enough for most things that you want to do. These were fairly expensive in their day, simply because they're, Racal Dana, which is pretty good stuff. And we look inside and you'll see how complicated it is. So it is held together with basically 2 screws back here in the back, and the cord is attached. I hate it when the cords are attached. It makes it so difficult to get apart and back together again. Okay. So, here we go. Here is the insides. This is a complicated little machine. I changed out the caps, and it doesn't have a lot of caps, but it's got a few. This is the top board. This is all frequency generation and logic, and all that kind of stuff. What was wrong with it originally was somebody, like I said, had magic screwdrivered this thing, and they broke this little trimmer right there was busted, and that's the 10 megahertz frequency reference. So it basically didn't work worth a hoot when I got it, but it was okay. I found one. I stole this out of an old board I had for a Yaesu F77 GX. It's 3 to 30 puff. So, and it fit. It wasn't exactly the same as if you look over here at these big guys that are in here. It has these guys right here, which are 3-legged. 2 of them are connected internally anyway, and this is the center. So for your frequency adjuster, for your capacitive adjustment, this little one, it was not it is not that way. It just has two legs, and but it works. It doesn't matter. It works fine. As long as it was the right capacitance, I was happy. So, fix that, and then I went about finding a manual for it, which like I said, I got online. The other thing I found out is as expensive as this thing was, it came with dirt cheap IC sockets. They're crap. They're ridiculous. But I did manage to pull all the ICs out, clean them all the sockets a little bit, and put them all back in, and that took care of a lot of the problems that it had right there. And it's the alignment of this thing is unique. But let's show you the bottom here. This board here is the actual sweep generator board, and it controls all your sweep functions. It comes off, there's a couple of screws right back here in the back that loosen up, and you can slide this whole board back and flip it over this way, but you really don't need to. There's holes in the top so that you can adjust everything you want to, and it's just, you have to take a couple of these off the front, and it's really kind of interesting. They thought of that when they built this, and you take these knobs off the front here. When you flip this board over, on the back side here, which would be the front of this board, there's a paper that tells you where you are on these knobs, and there's a knurled thing here on the knob, on the outside knob, with a long set screw sticking out of it that points to the position on the paper so that you can actually have this thing out and adjust it without counting which position you're on as you go around. I thought it was a nice little touch. But it's yeah, you don't have to take it out because all of the holes that you need for your adjustment are down in here. They drilled it through the board and you can get to them. Let's see. All of the pots in here, all of the adjustment pots are these big, tall, stand-up guys, and they're not very forgiving. They do get dirty, folks, and you have to clean them. And when you do clean them, then you got to wait for them to dry, and they're kind of a pain. But that's what they used in those days. There's no 10-turn pots on this at all, which is kind of a shame. And the way you adjust this is you set it on your different frequencies selectors, and you adjust the high and the low end, and then you just keep on going up, and eventually it gets up to the point where you're up to 20 megs, and then you go back and do the whole thing again. The big deal with this is this adjustment here for the frequency span. That is not, it's described in the book, but it's described and of course the SD card ran out of space right in the middle of this thing. Anyway, so I was going through it and all of the different parts that are in here. All of the switches were cleaned, of course, and the pots. Everything does more than one thing. You've got pots that slide back and forth, and everything has a switch and a pot on it, or two switches, or whatever. It's very common. Anyway, let's get into how this thing is tuned. It's a fairly complicated, It's a fairly complicated process. It does, however, work, and the way they set it up in the book is kind of interesting, in that you set it up for a standard setup, which, let's see if I'll show you here. There it is. This is your standard setup for the A1 board. You set all the switches to these positions, and then you go down and start doing stuff, and it tells you in the control setting here, like for this level adjustment, that you set it up for standard. You use test equipment as a digital voltmeter in DC and where you connect your connections. And then, but periodically it'll go down through and it'll say standard except the frequency multiplier at times 10K. This is great, except for, trust me, you forget to take it back to where it was, and you start doing an alignment someplace else, and then it doesn't match, and you go, oh, I gotta take it back. So you take it back, and then you go back through what you just did. Hopefully you didn't mess anything up from the previous section, but anyway, that's how it's set up. So this first section here, you look at the power supply, and you make sure there's plus or minus, it's got the voltage, and they're very critical about it, and you adjust R9 934, which is back here. Is that right? Yeah, 934, which is back here. And interestingly enough, I don't know, I'll see if I can pull this down here if you can see it. Everything on this board, let's see, yeah, there's a, right there, I'll show you. Everything on this board is handwritten. Right there. What does that say? Put on the geek glasses. You can see it better than I can, actually. This one. What? E405. And all of your test points on the board, fortunately, or virtually all of them, are like this. This resistor here with this, it's stood up and it has a bare lead, and as in everything else of this era, or actually any era, well, not so much now because they don't do that kind of stuff, but if you look over here, can't see it very well because the camera's in the way, but there's parts missing. Well, these parts are in the manual, but they're not on here. This particular one is for a fine adjustment, low-end fine adjustment. Underneath here, they just got a resistor put in there instead of, they figured they didn't need it, I guess. Whatever. What I was talking about before is over here. If we can get over here and see this. There's a couple of adjustments here and down here. These are the span of the frequency for the sweep, and let's see, this one is this one of these anyway is the span, and the other one is the null. What you do is you set your span up for maximum. You start at one low end of the dial, you set it up for maximum with one of these guys. I think it's this one. And then you bring it back down to 0, and you adjust this one so that you have no output. We'll see that, a little later on. But it's not described. It's in the book, but it's kind of weird the way they do it. But anyway, so I did the test on this, and it came out to exactly 15 volts. Then you go to your triangle generation, and this is where we'll start. So plug this thing into the isolation transformer just because it's here on the bench and that's what I use. And we'll turn it on. Okay, so she's on, and like any kind of piece of equipment these days, you want these things to warm up for quite a while. It hasn't, so we're going to break that rule right now. The one thing that up here that you really need to know, up in the service manual, or up in the manual here, is when you hook up your equipment to this thing has to see a 50 ohm load. So where did it go? Somewhere. Anyway, it requires that you have a 50 ohm load through to the to your scope, or nothing will be correct. So we have a 50 ohm load here, which we're going to put on our probe. There we go. And we'll get our scope lead. We're just sort of pausing here. If it ground, this turns out to be a good ground from what I found. So let's go to the first step. Not in the voltages, but let's go to the first step here. And I'm going to turn, let's see. All right. So, says to leave it in standard adjustment. So the standard adjustment is the frequency times 100, inner switch to times 1, the offset, or this dial to 8, right there. The offset selector to AC, centered across the 0 point. The waveform to triangle. The width and VAR symmetry for the pulse pushed in and fully clockwise. The sweep time selector outer switch to off. It's down here. The vernier to calibrate, which is turned all the way over that direction. The linear sweep on this particular one is pushed in, so that would be that one there, because we want it on linear, not log. The outer of the mode, we want to continuous frequency. The pulse width in the center to 1 to 100 microseconds. The output to 15 volts and turn to calibrate, which is over here, calibrate. And this to sweep ramp, which is down here. Alright, so everybody's good. And we go to our first test setup. Well, we're not going to do the voltage. Why not do the voltage? So we'll take our meter here and give it, separate out all the leads, give it a ground for the meter. Makes a good ground right there. Alright, and we will go to TP to the plus minus 15, or the plus 15 volt test point, which is somewhere around here. Yeah, plus 15 volts is right there. No, that's minus 15 volts. I've forgotten where the 15 volt test point is. Well, when all else fails, you can always look at the paper. If I can find it, I might actually have gotten rid of it. Well, fortunately, let's see, we're on page 36. So if we go down here, Let's see. There it is. We're on the A1 board, and our 15 volts test point is up here someplace. Alright, so okay, so our 15 volt test point is right at the end of this resistor, and we have 15.013. Okay, while we're at it, let's go to our negative. Let's see, that's 15. Our negative 15 volts is over here. Negative 15.015, that's fine. Our 25 volt test point, we'll get these out of the way. 24.9, negative 24.9. And our positive 25 volts, 24.91. Those are all well within specs. This is our 5 volt, 4.96. That's good enough. Okay, and let's see. That's it. That's all of our test points for voltage. So we know our voltages are correct. That's always the first thing you do. So now we go back up to 36. 37 actually, and we'll go for our first test. You know what? I'm going to print this out because so back up to page 37. All right, so we connect our voltmeter here to TP203, which is TP203, which is right here, and we should have, let's see, connect TP203 to ground. That's right, forget about that. And this is 203 is this little guy right here. So we take him and we attach him to ground. And we take a reading at TP205, which is right next to it. And waveform to DC. Let's try that again. That ain't right. So we want to adjust R216. That is not right at all. Alright, so we'll adjust it. We'll go over to the other meter here and see what we get with this one. Anyway, so basically you get the idea of how this thing tunes up, and there's all kinds of adjustments for it. I found that original adjustment that I did down there for the DC charge over here and the other this back and forth between these two really doesn't seem to make a lot of difference, and it's not nearly as critical as they say it is. So what we're going to do is we're going to now check and look at the output of this and see if we got anywhere even close. So let's hook up our scope. Yeah. Alright, so we'll hook our scope up to the output here with a 50 ohm dummy load on it, because that's what it says it wants. And turn it down a little bit, and we'll take this camera and we'll, well, tell you what, let's take this camera and use it for the scope. Lock the legs in, that'll help. Alright, so we're going to that camera for the scope, and this camera I think I'm going to have to put up here for frequency. So let's get another hunk of here, take that off of there, put the 50 ohms up here, put this over here. Yeah, riveting, isn't it? Okay. Alrighty, so let's give this thing a test just to see what it does. I went through the entire setup on it and got everything as close as I could, I think. So let's see what we've got. Alrighty, so frequency-wise, I'm on my 800. Frequency-wise, I've got 798. .800 hertz, right there. And if we look at our there, I don't know, can you see that? I can't tell if I can see that or not. Yeah, that's on 800. Yeah, just barely can't tell, but it's on 800. So we got 800 hertz right there, and our waveform looks beautiful. Let's actually, let's take a look at, we can do this another way. This is a storage scope. Take it down a little bit. Adjust our screen markers to right there, about as close as I can get, and we can see that it says, wow, focus. Focus. You're not going to focus. You don't like that. How about if we get a little closer? No. Well, okay, well, you can see up here it says 798. So, we got 798 hertz. Yeah, that's close. Alright, so let's take this times 1K and spread it out a little bit. And reposition this marker. get it on the right one. Hard to do. And we're looking at 8K. If we go up here, look at this guy up here, 8,015. I can turn it down a little bit. Oh, it's very touchy. There's 8,000. However, what we want to check is linearity. So let's take this thing down to, we're on times 1K, so let's go to 1,000. Adjust our markers again. Relatively difficult to do, but it says about 1,063, and the frequency counter says 1,071. So let's put that down. Touchy, 1,071, and we are sitting real close right there to 1,000. So let's take this up to 10,000. What do we got? We got 9,935 on the frequency counter. See right there. And it's just a twitch of the knob takes you to 10,000. And we'll come down here and take a look. We're darn close to 10,000 on that little knob right there. Like I said, these things are not going to be perfect. So let's do a sweep. Let's go from 1,000 hertz. Well, let's go from I don't know, let's see, about 200. Let's go from approximately 200. So basically, if we do this here, well, I wish this thing would focus. Just not going to focus. Okay, so basically we're looking at 200, 185. The frequency counter says 185. This thing is not real happy about this. But let's do a sweep here. And put it back on there. And let's give it a trigger and see if we can get it to sweep. Let's do it for a second, okay? There it goes. Get a little bit more. That's not much of a range, but that's how it sweeps. I'm hitting, and I'm doing this with the trigger button, so it sweeps across. Let's put this here, back. That's sweep and hold. So basically, I'm going from there to there. So now, let's do it all the way to 1K. That was, so back to 0. Now we're doing it from 200 to 10K. That's a good example of what happens when you're using a digital scope. Let's take this out. Take it back to 0. Okay, there I'm at 200 on triangle, and my sweep comes across to 10K. Back to 0 to 10K. That's the sweep and hold function. Okay, so let's do a continuous sweep. Where's continuous sweep? continuous sweep. There we go. Sweeping just like it's supposed to. And let's do a triggered sweep. Take it back and sweep. Triggered sweep starts at 0. You hit it and it sweeps and it goes back to 0. That's what it's supposed to do. And the sweep and hold sweeps up and stops. Oh, I'm not on sweep and hold. Now I'm on sweep and hold. Back to 4 or 200 and sweep in and hold. I must have turned, oh I did, I went to 10 seconds. Okay, there, sweep and hold. Back to 0, sweep and hold. Okay, so then you go over here to, keep turning the wrong knob, get over here to continuous, and basically your sweep does nothing anymore. You just got a continuous 200 hertz, which we can take up to 1K. That's easier to see. So there's 1K. Anyway, that's how that part works. I mean, it's just basically a sweep generator. But let's go, and here's my sine wave. The sine wave is not perfect on this thing, especially at the lower frequencies. Yeah, let's multiply it up a little bit. It's okay. And that's as clean as it gets. Trust me on this. Oh, now, here's your square wave. And that's continuous. But we can do a sweep and hold. We can do the square wave sweep too for testing amplifiers. And now let's do the, this is pulse. This is kind of hard to catch on this scope, but we'll do it. Okay, this is the pulse on 30 to 1,000. 1,000? Yeah, 30 to 1,000 nanoseconds. And I can turn my pulse width. This is the pulse width. That's 0. That's the crossing point between the pulse width. Wow. Hit everything, knock it all over, David. Alright, and I can I can invert it, like that. So I've got it inverted. Well, let's take this down to something that's actually a pulse that you can see. There's my pulse, and this is my pulse width. Whoops. Now this is actually easier to see on a, let's take the frequency down a little bit. Okay. There's my pulse, and now I can show you the pulse width. So I can vary that pulse width too, past the 0 point so the scope loses it. But there's your pulse width right there. And I can go from very fast to very slow. It's I don't even think I can capture this. No, I can't one. I could, let's see. Take this out to here. There it is. If you can see that way over there, there's my pulse width on about as fast as this thing will go. So anyway, so it does a bunch of stuff. Question is it as good as today's? Come on, focus. Thank you. Is it as good or even close to as good as today's equipment? The answer is no. This little guy right here does considerably more than this does. This was thousands of dollars. There's still $100 on eBay if you buy one. This was 87 or something like that. So, yeah, no, it's these things here are fun to have around, just because I'm basically geeky. I like this kind of stuff. But in today's world, that little guy up there is much more useful. However, that doesn't mean I'm going to throw this away. I'm going to keep this, and I'll use it unless somebody else has a dire need for one of them. But just wanted to show it to you and show you what this old stuff will do compared to today's new stuff. I must admit, the dialing in the frequency on here for what you want is much simpler than doing it on that thing. I mean, this, you just dial in a number, you look at it, you set your sweep to from where to where, and go. That thing up there is a much more involved process. So I want to go, let's see, I want to go from a kilohertz on my sweep. I want to start at 1 kilohertz linear. Let's see, sweep again, sweep begin frequency at 1,000, sweep end frequency at what do I want? 10,000, and I want it to go for 1 second, and I want to go. Okay, that's going, and it's doing what I told it to. It's doing exactly, well, let's take a look at it here. If you remember our sweep from before, it's doing exactly what I told it, the other one to do. Wait, stop. Okay, we want to go triangle. We want to do apples to apples here. Okay, so there's my triangle sweep, and it's going across, and it's doing exactly what this one did. However, it took a lot more time to set it up. Let's put it back on mine. Let's see, what am I running at here? This one I'm running at 0.6 volts. Let's get this one down to the same. So I'm starting at 1. I'm going 1 second, continuous sweep to 1 to 10,000. Triangle wave down. There you go. So there's this one. That's the F77 doing its sweep thingy, set up exactly the same as this other one. So let's hook this back up to this guy and go. So there you go. They do exactly the same thing for a lot less. And besides, this guy over here, that will do arbitrary functions. I can feed it. I can feed it in modulation, so I can have a modulated carrier or modulated sweep. It'll do, let's see, it's got a little cheap frequency counter built into it. It'll also do, let's see, what is it? On the external input, I can do FSK with it. I can do ASK with it. It's just, it'll do so much more, excuse me, than this guy. But you got to admit, this guy is a lot more impressive to look at. So, anyway, there you go. Hope you enjoyed it. Give it a thumbs up if you like it. And don't forget to subscribe.